All right, this one's going to have a good mix of coding and a good mix of lecturing because we're going to be talking about pointers ultimately. In order to demonstrate this idea, we're going to first do some coding on something called mouse. So write a class mouse whose objects will simulate the daily growth of lab mice. Implement the following public interface. Okay, here is our public interface. Although I see these things, they look a little bit different. I don't see these parentheses. I also see these plus signs, these minus signs. What's going on here? Well, let's tackle this stuff down here because we've seen this before. We should be able to identify this. This first thing is a constructor. Now, do I know there's no return type, same name as the class. And we see those parentheses. I have a second constructor, so we're overloading the constructor here, taking in 4 values. Double, 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 double. We also have this growth method, right, which doesn't return anything, equals, which we'll do much later, and then of course our toString. So what are these things? Well, these are actually instance variables, right? We're using a similar notation to kind of demonstrate what the instance variables return, right? You see the colon? This is saying that age is an integer. If you were to access age, you would effectively get back an integer, almost as if it's returning. So it's trying to use that syntax. Okay, what does this plus and minus mean? Well, the plus means public. You should see that on the public interface. And then we have the minus. This is stuff that's not normally included. This is private stuff, right? So the minus is going to mean private. This plus is going to mean public. You could choose to do this. If you feel like the name of your instance variable is extremely important, you could choose to do this. I'm showing this to just kind of easily show we're not going to have a debate about what instance variables belong in this mouse. I'm just going to go ahead and tell you these are the instance variables. So let's get started on coding this thing. I've already got IntelliJ up. I'm going to make a new project by going to File, New Project. We'll go next, next. I need to switch to my CSA folder, but you could already go ahead and start typing out mouse, likely. I'm going to ensure that I have a subfolder, and we're good to go. I'm going to expand my project folder, right-click on the SRC, make a new Java class called mouse. Okay. We're back on objects, right? We took a little stint, talked about static a good bit. I've got instance variables, right? We got this integer age, a weight, a growth rate change, okay? So let's start off with our age. We got private int age. And I think some good comments here for this are going to be like, what unit of measure is this in? Right? When we're talking about lab mice, the unfortunate fact, we're looking at days. Okay, our weight is going to be a double. Private double weight. What unit? This is in grams. I'm smiling because in past years I've had students say things like stones, and that's all I can think about is these ginormous lab mice. Our growth rate. Okay. What unit of measure do you think this is? I'm thinking something like grams per day, or it could be like a percent per day. Not super important. We can come back to it and change it if we need to. And then the last thing we're going to have is our growth rate change. I'm going to have to tab these over some more. What is this? This is like maybe a percentage per day. Like it is the amount that our growth rate is going to change. So simply put, the mouse gets bigger like over time. If I was doing this kind of ideally, we would like bell curve it, but that's too much, right? So we're just looking at percent per day. It's how much the growth rate changes. Okay. So here's our instance variables. It's stuff that we care about. We're ready to start doing our constructors. Now, in IntelliJ, the moment that you have instance variables, you can start auto inserting code. Right? I'm going to jump straight to this constructor. It simply put is just taking in values that correspond with these instance variables. So we get to initialize a mouse exactly like we want. So using some IntelliJ magic here, we're going to do Alt Insert in order to generate code. And what I want is a constructor. It's going to ask me which instance variables do I want involved in that constructor. Well, I want all four. A couple of ways, at least in Windows, where you can get all of them. One is Control A. That highlights everything. Another is to shift click. Right? Shift clicking is going to basically highlight the range beginning from where you currently have highlighted to where you click. And another is control clicking, which is individualized. Right? I'm going to show those just real quick again. Shift clicking, right, highlights that range. Control clicking is individualized. It'll just highlight the ones that you want. But pick your poison here. We're going to get a constructor inserted. All this is doing is looking at the instance variables we got, using those as the names in our constructor header. We're using this dot notation in order to take the local variable, this parameter age, and save it into our instance variable. Right? This is super clean, all thanks to this dot notation. I also have a Noargs constructor here. Right? It doesn't take in any parameters, any arguments. We need to get that one going. And the idea behind that one is it would kind of represent your average Joe mouse, right? How old is the mouse when it typically gets used in the lab? Day one. How much does the mouse weigh? That sort of thing. I don't really care here. I think it's kind of cool to look at values. How old is a mouse before used in a lab? Mine should be at least 10 months old for inclusion. That's interesting. 10 months. We'll go 30, so we're looking at what? Like 300 days old? That's surprising to me. All right, so our age is going to be 300. Our weight, how much does a lab mice weigh? House mice, deer mice, body weight information. We can go with this right here. Measured in ounces. That's surprising. Okay, we'll switch it to ounces. 0.68 ounces. Maybe the Google is just detecting that I'm an American, so it's using these make-believe units. All right, growth rate. I'm tired of research and stuff. Just come up with something. Growth rate. How many ounces per day is our mouse growing? I'm going to go with 7. And what is our growth rate change? Let's do something like 10%, and I'm going to log that as such. Okay. So the idea behind this Noargs constructor is it just represents kind of the average lab mouse, and the constructor is the initial state. So what I kind of am thinking is, what are these values for your typical mouse on day one that it enters the lab, right? Typical values for a lab mouse on day one. Sure. This is not day one of it being alive, right? Because it's 300 days old. This is day one of it entering the lab. Okay, that's the idea. Let's look at some of our other stuff we got going on. I don't have getters and setters shown. I don't think we'll ultimately need them because I think we're going to just look at a lot of data with our toString. So why don't we go ahead and get our toString in here. I'm going to do public string toString. The idea is to give us a string representation of our object. That's like all the instance variables. So what I'm going to do is kind of at the point of return here, just concatenate this large string that includes information about all this stuff. I want to say that the age of our lab mouse is age. I'm then going to use a new line escape sequence to create a new line here. This is technically a single character, right? So you could just do single quotes, whatever makes you happy. But we're going to go down to a new line. I'm ready for my weight. So I'm going to say weight plus our weight plus a new line character. Now, since this is a character, it could fit right into your string. What do I mean? This new line could be here. I personally don't like doing that because it gets a little bit convoluted. Thank goodness that we have colors here, right? Because if this wasn't color coded, it definitely would just like blend in. This becomes a mess. I like keeping it separate because I want my toString to be clean. I want it to be kind of a clean representation of what I should expect whenever I end up using it. Next, we're going to have our growth rate. And by the way, like things that you could consider including here are the units, right? Our age is measured in days, so you could consider including that in your output if you would like. Our weight is measured in ounces, unfortunately. Our growth rate, along with our growth rate variable, right? I'm going to pull that instance variable, and that is ounces per day. And lastly, we're going to have our growth rate change. I'll plug in the variable, and that is going to be percent per day. Now I'm going to end this with yet again another new line escape sequence. That way anything in the future that gets used is on a new line. And we could use system.out.print lines in order to achieve that, but we'll see if we need this or not. This is just like a formatting thing. So this is my toString. It's going to give me information about the state of the object, and the state, as you recall, is all of the instance variables. So it's going to tell me in one single method what the values of all the instance variables are. Let's create some mouse objects. I'm going to right click on the SRC, make a new Java class. We'll have a driver. I'll plug in a main method with PSVM. I'm going to create a mouse. This is going to call our Noargs constructor, which is going to give it all of these default values. Probably shouldn't say default. It's going to initialize it with these values. Okay, let's see what our mouse looks like by doing an SOP on Mickey. And if you'll recall, what we're implicitly doing is calling Mickey.toString. I'm going to right click in free space and tell this to run, and we'll see what our mouse looks like right away. Our age is 300 days. It weighs 0.68 ounces. Our growth rate is 7 ounces per day, and we're going to increase that by 10% per day. Okay. Let's create maybe a second mouse, and we'll use this constructor in order to achieve that. I'm going to create a mouse, a Remy. It's a new mouse. I believe this is like a Ratatouille reference. I don't know. Somebody gave it to me last year. What am I doing? We're using this constructor, right? This is the part where I would normally ask for things like an age. 17, and that's days. The weight is got to be lower than 0.68, right? It's 0.3, and the growth rate on this mouse is 17. And we'll increase at, I don't know, 50% per day. Remy's going to be a thick boy. Not initially, but eventually. All right, let's take a look at what Remy looks like initially. Right, this is going to be Mickey, and this is going to be Remy. I would maybe even consider annotating this. All right, we got Mickey. And I'm going to throw in a new line character there. I got Remy. I'm going to run it again. Oh, I want a colon on that one. Okay. Now, you may be asking, well, why aren't we doing this in the toString? Right? I've got these named variables, and so I'm including that here. Simply put, you can't, right? This here inside the object actually doesn't know what variable is referencing it, is pointing at it. We're going to talk about pointers here in just a moment, and the object doesn't know what the name of this variable is, which is ultimately why we're doing it there. Now, what we could do is include some type of name instance variable, and maybe that is something that we take in, right, whenever we create the object. I don't typically recommend naming your lab mice. They're not around for too long. Don't get attached. All right, we're looking at this grow method. The idea behind the grow method is going to simulate 1 day of growth. Right, keep in mind we have this these instance variables. Particularly, we have our growth rate per day and our growth rate change per day. So we want our grow method to use those things and coincide, and so it's going to need to simulate 1 day of growth. We got public void grow. I'm going to Java doc this. Simply put, grow simulates 1 day of growth. Okay. This would be a good one to maybe pause on if you want to attempt this on your own, but we need to update the state of our object, right? This is going to ultimately be a mutator because it's going to change our object. It needs to update the age and the weight. The weight is going to update based on our growth rate and our growth rate change. So here we go. I'm going to code it. Age has got to be the easiest one, right? Age is represented in days. This is 1 day of growth. Age plus plus. Done. Our mouse is 1 day older. Okay. Our weight, a little bit harder, right? It's in ounces. It's going to grow this amount per day. So I'm going to take the weight, and not too hard, right? Since they're both in ounces, no unit conversion or anything crazy here. I'm just going to take the weight, and I'm going to say plus equals our growth rate. Right? We're going to gain this many ounces on this 1 day. The last thing I need to do is actually update my growth rate because it's going to increase by a percentage. Again, ideally I would like bell curve this because otherwise our mouse is just going to get bigger and bigger and bigger at a faster and faster rate, kind of indefinitely until it explodes from all the lab experiments that we're doing on it. So we're going to take our growth rate and it needs to update. This is ultimately a percentage, so you got to think about some type of formula. Right? This is going to be what it currently is, but it's going to increase by this percentage. So what we're looking at is that our growth rate is going to become what it currently is, plus, or you can do, so yeah, you can do plus 1 plus, I should say times, right? Times our growth rate change. Okay, so let's think about this for a moment. All right, our growth rate is initially 7. So what I'm saying is 7 times, and I think the inclination is to then do growth rate change, right, which is 0.1, right, 10%. Okay, well, if you do this, this is going to be like, what, 0.7? And you're saying that the new growth rate is 0.7? No. What I want is I want this to increase by this amount, right? So I effectively want it to be 110% of what it is. And that's where the 1 comes in. So the way our formula looks is we're looking at 1 plus 0.1. So this is going to give me, right, 1.1 here. And then 7 times the 1.1 should be like 7.7. So that's the idea behind our formula. This grow method should simulate 1 day. We're going to get 1 day older. Our weight is going to increase based on our growth rate. And then after we do that, I'll update the growth rate so that the next time we try to grow, we're going to be a little bit larger. There could be some argument on, should we do this first? Whatever. I'm going to hop over to my driver and let's test out this grow method. I'm going to take Mickey and tell him to grow. Right? We're going to do Mickey dot grow. Okay, I'm kind of already doing this because I'm doing something silly. I'm running the program, and you're like, whoa, what happened? Where's Mickey? Why don't we comment out Remy for now? I'm going to highlight those lines and hit Control /. Well, is it just not working? What's going on here? We see Mickey in its original state. I tell it to grow, and I don't see anything. That's because we didn't print it, right? The grow method is mutating. It's not necessarily giving us back information. Why don't we just grab this guy with a little copy and paste magic. So I'm going to construct my mouse object. We'll see what the initial state looks like. I'll tell Mickey to grow, and we'll see what the changes are. All right, here we are after 1 whole day. We see Mickey is 1 day older. Mickey is, looks like Mickey devoured a few other mice because, wow, we got really big. And then our growth rate now, so the next time that we tell our mouse to grow, it's actually going to be a little bit bigger at a little bit faster rate because we increased by 10%. Okay. Why don't we speed up this process? I'm going to include a loop. And let's say that I wanted to do like 10 days of growth. Okay. We're going to see Mickey in the initial state. I'm going to use a loop and tell Mickey to grow 10 times. That's going to be 10 days of growth. We'll see what Mickey looks like after those 10 days. And you see we're on day 310, so we've done 10 additional days. He's gotten quite hefty. We're now up to gaining about 18 ounces per day, and that'll continue to increase by 10%. Okay, so that's our grow method. Sweet. So we did our instance variables, we did these constructors, we did the grow method, we did a toString. We're going to come back to this equals because we want to talk about a couple of things. We want to talk about pointers. Okay, usually an object is constructed and saved into a variable using one single construction statement. I'm going to stress this a couple of times throughout the year. Right? We do this so often where we construct an object and save it into a variable all in one line. It's important to remember that the construction statement is effectively doing two different things. The left-hand side is variable declaration. Right? We got a data type, we got a variable name. This variable Mickey can point to or reference, it can save, if you will, mouse objects. That's what this is saying. The right-hand side is the actual construction of the object. It's making a new object. And here we see an actual call to the construction statement. This can be broken apart. We do this so often, but it can be broken apart into its steps, right? Variable declaration happening on the left-hand side, object construction happening on the right-hand side. Now, this looks a little bit weird, but we do this all the time. Right? We do this with strings, for instance, with instance variables. Right? We declare the instance variables in the body of a class, and we don't initialize it. We don't give it a value until the constructor. So this actually happens a lot, despite the fact that we've been doing this a lot. Understanding that the variable is a separate entity from the object is important, as variables can change. That is, they can point to or reference different objects over their lifespan. To fully understand pointers, let's visually represent what is happening with this construction statement. So what I'm going to keep track of are variables, and I'm going to keep track of objects. They're two separate entities. I'm going to try to say that they're on two separate lists. So let's bring in our construction statement, and let's visually look at what's happened. Right, the right-hand side, a new mouse object is constructed and stored in memory. And you see that over here on my objects, we've got a mouse there. The left-hand side, variable declaration, we're going to create Mickey. Right? It's able to reference mouse objects. Then the assignment operator here, since this is an object and an object variable, we're going to tell that variable to point to this object. Visually looks something like this. What I'm trying to get you to recognize is they're two separate entities. The variable is separate from the object. If I come in and introduce Remy to the mix, right, we got a construction statement. We're going to create a new mouse on the right-hand side that gets added to my objects. We got a variable declaration over here on the left-hand side. We're creating Remy. Add that to my list of variables. And then I'm going to use the assignment operator to tell that variable to point to this object. So we see variables are pointing to their respective objects, right? However, in the same way that we can reassign primitive data type variables, we can reassign object variables. Left-hand side, we're looking at a primitive data type. We're looking at an integer x. I give it an initial value of 7. I then later change it to 14. It's a variable. That's the whole point, right? You're able to change it over its lifespan. Well, these are object variables, meaning they can change. Right here I have mouse Mickey. It's a new mouse. Later on, I'm going to take Mickey. Notice there's no data type because I'm not trying to redeclare the variable. I'm just trying to assign it a new value. I'm trying to change the pointer. Right, so initially, we're going to do this construction statement up top where we create our new mouse called Mickey. The assignment operator is going to tell it to point to this mouse. Then I'm going to create a new mouse. I'm going to take Mickey. We're not trying to recreate it, so we won't see anything added to this variable list over here. But we are going to take it, use the assignment operator to point to that mouse that I just made. Okay. Something that's going to be kind of interesting is what happens to this guy? Right? This mouse is effectively dead to us because there's nothing that's referencing it. Right? The only way that we can get to these objects are by going through these variables. What do I mean? Well, look at here, right? Once I have Mickey, the way that I refer to it is by talking about the variable. So if there's no variable that is referencing the object, what happens to it? Well, there's something known as the Java garbage collector that'll delete these things. It goes through and checks to see, are there any references to these objects? And if there are no references, it assumes that you're done with it and deletes them from memory. And other programming languages, something like C++ is a very notable one. You manage this yourself. You manage the pointers, meaning you tell the programming language when you're done with the object, and it will delete it from there. Java's tried to automate this, right? And there's some running jokes with the typical update to Java. All they're doing is improving garbage collection, which is they're trying to automate the process, determine when to delete the object. And so it's just like, you look through the patch notes and you're like, oh, it's nothing but improvements to the garbage collector. And it's been like that for years. So that is kind of a running joke. The other running joke is, well, when does the garbage collector actually run? Obvious, it's Monday. Monday mornings is when the garbage collector comes and gets the garbage. Reassigning object variables becomes more interesting when you tell the variable to point to the same object that another variable was pointing to. What we previously looked at, we were telling Mickey to point to a brand new mouse. But what this is saying is what we could do is tell a variable to point to another variable. Let's see what that looks like. Right? I've got Mickey in here. I've made Mickey grow a good bit. I'm going to come in here and create, we'll go with Remy. And instead of going through a constructor to create Remy, what I'm going to do is have Remy point to Mickey. Why don't we see what this state of Remy looks like? What do you expect? Right? The way our program is laid out, we create Mickey. We see what Mickey looks like. We tell Mickey to grow for 10 days. We then see what Mickey looks like after those 10 days. I then create this variable, Remy, and tell it to point to Mickey, and I see what Remy looks like. And here we go. So we see the three SOPs. Here's Mickey, its initial state. Here is Mickey after 10 days. Here is what must be Remy. Why don't I grab this? Here is what must be Remy, and we see it is the exact same state as Mickey. Now, logically, this makes some sense, right? I'm setting them to be equal. This is effectively saying I want these things to be equal. But what is happening behind the scenes, right? Visually, what does this look like? We have Mickey being created. It's a brand new mouse. So we got this whole setup: the mouse object, the mouse variable that's pointing at that object. We then come in and say that Remy is equal to Mickey. Well, this is variable declaration, right? So we're going to create that variable on the left-hand side. We're then going to use the assignment operator to tell it to point to Mickey. But, with our pointers, what that means is that Remy is pointing at the same mouse object. This is why it's so important to recognize that these are separate entities. The variable is separate from the object. Why? Because I have two variables that are actually pointing to or referencing the same object. That's why they have the same state. It's literally the same object. Right? I'm going through a different variable, but it's the same object. In essence, we're giving Mickey and Remy the same state. In fact, Mickey and Remy are pointing to the same object. Okay, here's where it gets interesting. Mutating the object that Mickey points to will mutate the object that Remy points to, and vice versa. It's the same object. In the situation I'm in now, I've got two variables pointing at one object. Okay, what happens if I update Remy? I'm going to tell Remy to grow by 1 day. Well, we'll then take a look at Remy. But I'm also, while we're at it, going to take a look at Mickey. Right, here we see Remy at the 310. That's this SOP right here. I then tell Remy to grow. We see the 1 day of growth. But while we're at it, I'm going to check Mickey, and you see that Mickey also grew by 1 day. That's because these two variables, they have the same state because they're referencing the same object. If I tell Remy to grow, it's going to also make Mickey grow because it's the same object. Okay. What if I asked, are they equal? Right? We have Mickey, it's a new mouse. We got Remy that's pointing at the same thing that Mickey does. What happens? What do you think we're going to get here? We're going to do system.out.println Mickey equals Remy. Or you could flip that. I suspect true because I'm asking, are these things the same? Right? In essence, I'm asking, are these equivalent? We use this relational operator on primitive data types. I've told you, don't use it for objects. Stay away from it. Notice it's not a syntax error. This actually works. Right? I'm taking this variable and I'm asking, is Mickey equal to Remy? True. Right? When two object variables are compared using the equals relational operator, their pointers are checked. Right? We're using this assuming it's checking for equivalency. I get the correct answer. I'm asking, are Mickey and Remy the same in my program? And it's saying, yeah. But what I'm actually doing is asking, are they pointing to the same thing? The equals relational operator asks, are these two object variables pointing at or referencing the same object? That's not exactly the same thing as asking, do they have the same state? Right? We are getting the quote-unquote correct answer here, but I'm asking the wrong question. With this equals relational operator, I'm asking, are these two variables pointing at the same object? And true, they are. What if I actually do want to know, do they have the same state? Because it's possible to have two objects that have the same state but be different objects. Right? State, as you'll remember, is comprised of instance variables. All of the instance variables are what I'm talking about when I'm talking about state. Okay? For that, that's where the equals method comes in. You've seen an equals method. We've used it with string, right? The equals method is to determine if two objects have the same state. This is a design philosophy, right? Not syntax. We're going to create an equals method to determine if two mouse objects have the same state. One of the objects is coming in as an explicit parameter, right? We see that here. Right? Let's break apart this signature. This is going to be in the mouse class. The name of the method is equals. It's going to take in a single mouse object. It's going to return a Boolean. And we don't see an underline. This is not a static method. This is an instance method, meaning we will need a mouse object. So you see this mouse here coming in as an explicit parameter. I'm telling you that the equals method compares two mouse objects. Where's the other mouse? Well, the other mouse is the implicit parameter, right? This thing is not static. That means you need a mouse in order to call the method. You need an implicit parameter. Effectively, the other mouse is this. Okay, so the equals method is going to return true if this mouse has the same state as the other, false otherwise. All right, I'm going to speed this up a little bit. I'm going to copy and paste this. Let's grab this, and I'm going to flip over to my mouse. I'm going to insert this equals method. Okay, it doesn't matter where it goes. I tend to put it like right above the toString. Right, toString and equals are very common methods. So the equals method here, it's going to take in this one mouse object as an explicit parameter. Right, returns true if this mouse has the same state as other being the explicit parameter. The question is, where is, I see one mouse, where's the other one? Where's the other mouse? And the answer is this. What do I mean? Well, I'm going to compare these two mouse objects to see if they have the same state. I'm going to check their instance variables. I want to know, do they have the same age? Do they have the same weight? Do they have the same growth rate? Do they have the same growth rate change? If so, they have the same state and thus are equal. Okay? Now, I know some of you are going to recognize that the chance that two mouse objects are like literally the same in the real world is extremely low. The other place we've seen this equals method is something like string, and that happens all the time, right? To have text that is equal. The concept is still the same. We're going to take two mouse objects and ask, are they equal? Well, I want to know, is this mouse's age equal to the other mouse's age? Right? I told you there's two mouse objects involved. This is how we refer to the implicit parameter. It's the mouse that calls the equals method. It's what's going to appear on the left-hand side of this equals whenever we call it. Other is the explicit parameter that's coming in. So we're going to compare the age of the implicit parameter to the age of the explicit parameter, right? Okay, something that throws students off here, it's a little bit awkward, seemingly, is that we see age. Age is private, right? But I'm not going through an accessor to get this one. This is fine here. We do this all the time. In fact, we did it in our constructor, right? Where I took this.age and I was able to refer to it with no problems. This is a little bit weird because it looks like I'm going into the mouse object and pulling out its age without going through a getter, and that seems weird because age is private. I was very careful with my word choice when I first talked about private. Private restricts access to the class that it is defined in. We are in that class. We are in the mouse class. I can see age. That's where it's a little bit confusing, but that's where I try to be a little particular with my word choice. We're able to do this because we're in this class. We're in the mouse class, so I can just directly grab the age. Right? This isn't an abstract concept. That's not what private is trying to enforce. It's just an access concept, right? We're trying to basically enforce security. So if the age of the implicit parameter is equal to the age of the explicit parameter, and I'm just going to do this all at the point of return, right? If the age is equal and the weights are equal, right? The weight of this is equal to the weight of the other, and the growth rates are the same, and lastly, the growth rate changes are the same, then we would say the two objects are equal. They have the exact same state. Now, I like using this dot here because it clearly shows where the other mouse is coming from, the implicit parameter. Of note, you don't have to, right? In this scope, when I refer to simply age, it knows what age you're talking about, right? It is going to assume this dot age. Maybe we leave that over here as a comment. So you don't have to use this dot here in this scope, in this context, but if it helps you recognize what's going on, by all means use it. Let's test this thing out. Okay. Why don't I, Remy and Mickey have gotten a little out of hand here. Why don't I get rid of both of them? Okay, here's what we're going to do. First of all, I want to show you the opposite of this. Let's just make two new mice objects. I'm going to create mouse Pinky, and we'll just go through the Noargs constructor. I'm going to create a mouse Brain, and we'll go through the Noargs constructor for that. Okay, I want to show why this is erroneous and why we want the equals method that we wrote. I've created Pinky, I've created Brain. Notice that Pinky is pointing at a new mouse object. Brain is pointing at a new mouse object. Now these are both going through the same constructor, which means they're going to have the same state. But what happens if I ask, is Pinky equal to Brain? Right? In theory, this is why I said you should avoid this. It's a little bit erroneous because it didn't do what you technically thought it was supposed to. Let's take a look. I'm asking, is Pinky equal to Brain? And we get false. Because what this does is it checks pointers. It's asking, is Pinky pointing at the same thing that Brain is? And the answer is no. They're pointing at two distinct objects. Well, if you want to know, do they have the same state? You'll ask, does Pinky equal Brain? Okay, I'm going to run that and we'll talk about this method call. And that is true. These things are equal. Okay, so this is what we mean by this is an instance method and you need an object in order to use it. Pinky is not a class, right? We worked with static a good bit. This is not a class. This is an object. So I'm asking, is this object equal to Brain? Okay, that's my two objects, Pinky and Brain. Back in my my mouse class, the way that we refer to the implicit parameter is using the this dot notation. That's how we're able to talk about Pinky here in this context. Brain comes in as other, and so that's where the two mouse objects, that's how they get into this side over here, so we can evaluate them to check to see, do they have the same state. Let's modify one of them. Right, I'm going to maybe take Pinky and tell it to grow one day. I'm then going to ask, are they equal? Pinky equals Brain. Our answer here should clearly be false because we have grown one day. But that's going to be it. This has been quite a bit. Mouse, this has been pointers. I'll see you in the next one.